All right, we're using conjugates, limits using conjugates here. So one thing, just as a default method, notice that if you wanted to, you can use Desmos and see what this, type all this in and see what happens as we approach -3. Remember, you're not actually plugging in -3. You'd want to approach it from the left and the right. All right, but let's see how to do the math to use the conjugate idea. Conjugate means that you have two terms and you're just switching the minus to plus sign in between the two terms. All right. Now it's appropriate to kind of get rid of things, or in this case, to try to cancel out our problem area. Notice that if I plug -3 in here, I have 0 on the bottom, and we're kind of stuck as soon as we have 0 on the bottom. So can I cancel the bottom out? Meaning I try to get rid of the top or manipulate it in a way to help pull an x plus 3 out. So notice there's a minus sign right here. So multiplying by the conjugate means I'm going to multiply top and bottom by square root 4x plus 28 plus 4. That's the conjugate idea. You just flip that middle sign right there. If that was a plus, I'd make this a minus. Since that's a minus, I make this a plus. And what you do on the top, you have to do on the bottom to keep the balance. All right. So this distributes, and it's like a difference of squares. That's the key for the limits by conjugates, is it's a difference of squares idea. So that means, and you could multiply this out if you wanted to. It's all of this times all of this. You'd have to FOIL it or use the generic rectangle, however you would do it. The bottom, you don't multiply out. You're trying to cancel the x plus 3. All right. So basically, so what this is saying is that if I have x plus y, so this is just my side work to show you, times x minus y, that's what I got here. I got one term minus the other term, same term plus the other term. That would give me x squared minus y squared, right? That's the difference of squares idea. We're going the other direction on this. So that means it's the first term squared, which would be 4x plus 28. So that one squared, minus the second one squared. So 4 squared is 16. All right. So I don't want to skip any steps. So I'm not going to multiply it out because that's real rigorous. But it's the 4x plus 28 squared minus 4 squared. So if this is the x, this is the y, it turns into this form right here. All right. So now I go ahead and combine what I can. So this is still side work. All right. So I'm just trying to simplify. I'm simplifying the top here. So this is the top of the fraction. Side work for the top. All right. So 4x plus 28 minus 16 is 12. There's a common 4 in here, and I get x plus 3 left inside. All right, so this was all the side work on the top. So this all turns into the limit as x goes to -3 from both sides. All the top turned into 4 times x plus 3. The bottom is our x plus 3 times what I multiplied through by. Right? So what cancels? Our problem canceled. The x plus 3, where it went to 0 on the bottom. So that means now I can just plug in the -3 into here and simplify because the problem area is gone. You should get the same answer if you plug it in on Desmos, but the problem here with the graphing calculator, maybe your answer is a radical or a endless fraction. You're not going to be able to see that very well, usually on the graphing calculator. Okay. All right, so the answer would be 4. I didn't do that on purpose. That was the mouse. On the bottom is 4 times negative 3 plus 28, and all of that plus 4. All of this is on the bottom of that fraction. Okay, and simplifying, I got 4 on the top. Negative 12 square root, negative 12 plus 28. So I have a plus 4 on the bottom. 4 on the top. And square root, negative 12 plus 28 is 16. Plus 4. 4 over 4 plus 4. 4 over 8. Final answer, 1/2. So on this one right here, you probably would have got 0.5 if you had kind of done it that same way. But notice the trick is you got to use the conjugate to kind of simplify things. Your goal is to cancel. If it doesn't cancel, then it would do not exist. But there's our answer right there, 1/2. Okay, and if you're not sure, use the hint. So same type of problem. You always want to check if you plug in your number, does it go to 0? If it does on the bottom, then you'll have to try to manipulate it if you can using the conjugate. Same style of problem.